Number 13, we're asked to find and classify the critical point of this function of two variables here. How do we find the critical point? We start off by looking for when the partial derivatives are both 0. So let's calculate partial derivatives here. Partial derivative of f with respect to x is 4 minus 0 minus 1 over x plus y. Partial derivative of this with respect to y is negative 4y minus 1 over x plus y. And so we want to set each one of these to 0. Okay, so moving both of these have negative 1 over x plus y terms on the left, so let's rearrange them to get 4 is equal to 1 over x plus y, and this is negative 4y is equal to 1 over x plus y. And let's realize here that if 4 is equal to this and negative 4y is also equal to the same thing, we can use that to conclude that 4 must equal negative 4y, which is true exactly when y is equal to negative 1. Okay, so if y is equal to negative 1, let's plop that into our equation that involves x here. So we'd have 4 is equal to 1 over x minus 1. Multiplying on both sides here by x minus 1, we get 4x minus 4 is equal to 1. 4x is equal to 5, so x is equal to 5 over 4. Okay, so far, so good. We have our critical point here, and we found only one critical point. It's going to be 5/4, comma, negative 1. Okay, so then I should point out, you might wonder, do we have to worry about the partial derivatives being undefined here? Well, the partial derivatives are going to be undefined if x plus y is equal to 0, but if x plus y is equal to 0, natural log of x plus y would be undefined originally, so those values of x plus y would not be in the domain of our function of two variables. Okay, so we've got our critical point. Let's classify it. In order to classify it, we need to compute the discriminant, the Hessian. And let's go through. First, we need all of the second order partial derivatives. So if we take let me just recopy f sub x and f sub y here. F sub x is 4 minus, I'm going to write as x plus y to the negative first power. F sub y is negative 4y minus x plus y to the negative first power. So f sub xx here would be derivative of this is 0, then minus, bring that minus 1 is plus, x plus y to the negative second power. F sub yy is going to be negative 4, and then plus x plus y to the negative second power. And f sub xy, the partial derivative of this with respect to y, is just going to be x plus y to the negative second power. Okay, so now the thing that we do, let's go ahead and compute all of the second order partial derivatives at the point 5/4 1. And so at 5/4 negative 1 here. So f sub xx will be 5/4 minus 1 to the minus second power. 5/4 minus 1 will be 1/4 to the negative second power. That's 16. And so then we can see this one down here is the same thing as also 16. And then this one would be negative 4 plus 16 is 12. Okay, so the last thing we have to do is calculate out the discriminant and classify. So our discriminant is, remember the formula, f sub xx, f sub, yy minus f sub xy squared. And so this is going to be 16 times 12 minus 16 squared. And this is going to come out as something negative. This is going to come out, it looks like, as, let's see here, negative 64. Negative 64 here. And so how do we classify this? This is something that's negative, and the negative discriminant here means that we have a saddle point. So this function f of xy has one critical point at 5/4, negative 1, and it's a saddle point.